Hello, everyone, and welcome. I'm excited to have you here today. We're going to dive into how to optimize performance in PowerBI and other data platforms. The title of today's presentation is Optimizing Performance in PowerBI and Data Platforms, with a focus on insights, tools, and best practices for efficient data management and querying. Over the next few minutes, I'll be sharing key strategies to help you work more effectively with your data. So let's get started. Let's dive into the context and background of performance testing, focusing on how we can optimize performance in PowerBI and other data platforms. As we progress, you'll see that this journey emphasizes the importance of continuous learning. Staying updated with new tools and techniques is absolutely crucial if we want to stay ahead in performance testing. I personally evolved my approach after discovering some outstanding performance tests created by MIM. Their work inspired me to seek out expert insights rather than trying to reinvent the wheel every time. It's a reminder that learning from others can save us a lot of time and effort. A significant part of my testing involved exploring Microsoft features. I found that many features only perform well under very specific conditions, which means understanding these nuances is key to optimizing performance. And it's also important to highlight that I come from a business background rather than an IT background. This gives me a unique perspective on performance testing, focusing more on practical outcomes and business impact rather than just technical details. Overall, this slide underscores that continuous learning, leveraging expert knowledge, and understanding specific feature behaviors are all vital components of successful performance testing. Let's take a closer look at the evolution of performance testing in PowerBI and its limitations. As many of you know, PowerBI is an incredibly powerful tool, but our experience has shown that it can't solve every performance challenge on its own. There are boundaries to what PowerBI can handle, especially when it comes to complex or large-scale data scenarios. These limitations highlighted the need for more advanced solutions, which led to the development of tools like Dataflow Gen 2. These innovations help us push beyond PowerBI's native boundaries and improve performance. However, challenges still arise, particularly when projects demand data refreshes as frequent as every 5 minutes. Power Query, which is integral to PowerBI, struggles to keep up with such rapid update cycles effectively. Looking back about 5 years, PowerBI and Power Query were really the primary tools available to us for data modeling and transformation. They served us well, but as data needs grew more demanding, so did the necessity for more sophisticated approaches. This historical context helps us understand why continuous improvements and new tools are essential in our journey to optimize performance and meet modern data requirements. Let's explore how tools and reducing friction play a critical role in optimizing performance in PowerBI and other data platforms. First, we prioritize tools that align well with real-world workflows. This approach ensures that we're working efficiently and effectively without adding unnecessary complexity to our processes. A practical approach to selecting tools is essential. By focusing on what really fits our daily workflows, we can avoid the trap of overcomplicating things. Hands-on experimentation has shown us that first impressions matter a lot. How easy a tool is to use can often be more important than its raw power. Many powerful tools come with complex setup requirements, which can be a barrier to initial adoption. That's why I emphasize a preference for tools that have minimal friction, tools that are straightforward, quick to test, and easy to integrate into our routines. Ultimately, the goal is to choose tools that streamline our work, reduce unnecessary hurdles, and help us move faster while maintaining accuracy and quality. Let's talk about how AI tools are really transforming the way developers work. They help streamline workflows, so instead of spending time on repetitive coding tasks, developers can focus on higher-level, more strategic work. This not only speeds up development, but also allows for more creative problem-solving. One of the powerful aspects of this approach is democratizing coding. It enables users to concentrate on the logic and testing of their applications rather than getting bogged down by syntax or API details. Essentially, AI makes coding more accessible to a broader range of people. Even if someone doesn't have extensive coding experience, they can still produce functional and optimized code. By iterating with AI feedback, users can improve their script step by step, making the process more intuitive and less intimidating. For example, I personally use AI to create Python scripts and SQL transformations, which significantly cuts down development time. This hands-on experience shows how AI accelerates the entire process, freeing us up to focus on the bigger picture. Tools like GitHub Copilot and large language models have truly revolutionized how we write ETL processes and perform performance testing. They help automate complex coding tasks and improve accuracy, making our work more efficient and reliable. Overall, AI is playing a crucial role in transforming code writing, making it faster, more accessible, and more efficient, especially when it comes to optimizing performance in PowerBI and other data platforms. Let's talk about performance management on OneLake and how Parquet file optimization plays a crucial role. When working with external data sources like BigQuery or Iceberg, optimizing how you read Parquet files can significantly improve your query speeds. Being aware of these nuances allows us to tweak the data layout, leading to better performance overall. One common issue is that files produced outside of Fabric sometimes have suboptimal row group sizes, which can slow down queries. PowerBI, in particular, performs best when the row groups are large, ideally between 4 to 8 million rows. So, understanding how Parquet files are laid out is essential for effective performance management on OneLake. By paying attention to these details, we can ensure our data is structured in a way that maximizes speed and efficiency, making our data workflows smoother and more responsive. Let's talk about the small file problem and some strategies to address it. When working with lakehouses, optimizing commands don't run automatically like they do in data warehouses. Instead, you need to schedule these as maintenance jobs to keep things running smoothly. Data warehouses, on the other hand, handle this automatically, so it's one less thing to worry about. Now, external data sources also face challenges with small files. They require manual optimization because the system doesn't automatically take care of it, making it important to set up regular maintenance to prevent performance issues. Fabric Spark offers some relief here. It automatically optimizes file sizes by default, which helps improve overall performance without extra effort on our part. But beyond that, compaction is a crucial strategy. Merging small files into larger ones, known as compaction, is often overlooked but is essential. If small files pile up, they can severely degrade performance across all application engines, not just PowerBI. So the impact of many small files is significant. They slow down data processing and analysis, making our systems less efficient. Addressing this small file problem through scheduled maintenance and proper compaction strategies is key to maintaining optimal performance across our data platforms. Let's take a moment to understand the key differences between direct lake and data warehouse optimization approaches. When it comes to data warehouses, they tend to trade some level of control for automatic optimizations. This design choice actually simplifies maintenance because many of the complex tasks are handled behind the scenes. The decision to choose between these approaches really depends on what your organization values more, control or convenience. For example, lakehouse platforms like Fabric Spark give you more hands-on control over how data is laid out and optimized. This means you're responsible for managing components like file compaction, which can be a bit more involved. On the other hand, Databricks, by default, produces highly optimized Parquet files, making things easier out of the box. But keep in mind, other vendors might not offer the same level of default optimization, so you may need to do more manual work there. Overall, understanding these differences helps us choose the best approach based on whether we prioritize control or simplicity in our data environment. When I look back on my decade of experience in this field, one thing stands out clearly. Pre-sorted data can make a real difference in performance. It's a simple concept, but when applied correctly, it can lead to significant improvements. You don't need complicated rules to get these gains. Often, focusing on columns with fewer distinct values or those used for date filtering can give you the best results. It's about prioritizing what matters most for your specific data and queries. Sorting data helps align it with how the query engine expects to process it. This alignment reduces the processing overhead, making everything run more smoothly and efficiently. Interestingly, despite how effective this is, I've noticed that sorting data before loading it into models is rarely discussed or even documented openly. It's one of those best practices that's often overlooked, yet it can have a huge impact. In fact, pre-sorting your data can speed up load times by up to 80% and significantly boost query responsiveness. It's a simple step, but when integrated into your workflow, it can dramatically enhance overall performance. In this slide, we're focusing on how our benchmarking process simulates real-world scenarios by testing with 16 concurrent users. This approach really moves beyond traditional static benchmarks, giving us valuable insights into how PowerBI and data platforms perform under actual user load. It's all about understanding how query performance holds up when multiple users are active at the same time. What's exciting is that the benchmark can generate data and semantic models in any workspace, which shows just how flexible and scalable this method is. We're not limited to a specific environment, and that adaptability is key for diverse organizational needs. Additionally, by integrating Python in Fabric, we can configure processing cores and simulate these concurrent user scenarios seamlessly. This level of automation makes the testing process efficient and consistent. And to top it off, we developed a fully automated benchmark that tests performance across 3 different semantic model modes: direct lake, direct query, and dual mode. This comprehensive testing provides a clear picture of how each mode performs dynamically, helping us optimize and choose the best approach for different use cases. Overall, this slide underscores the importance of dynamic testing in delivering real-world insights and ensuring our platforms can handle the demands of actual users. Let's take a closer look at the benchmark results for different modes: direct lake, direct query, and dual mode, and see how they perform in real-world scenarios. Modern PowerBI Fabric architectures are designed specifically to handle high levels of concurrency efficiently, which means multiple users can access and analyze data at the same time without sacrificing performance. This is crucial in enterprise environments where responsiveness matters. One of the key highlights here is that 90% of queries, or the P90 performance metric, complete in under 1 second. That's a significant indicator that most user interactions will feel instant and smooth. And speaking of speed, the direct lake mode really shines. It achieves an average query time of just 0.09 seconds. That's incredibly fast, enabling near real-time analysis and decision-making. Overall, these results demonstrate how modern architectures are optimized for both high concurrency and low latency, allowing users to work seamlessly without delays. This aligns perfectly with our goal of delivering a high-performance, scalable data platform that meets the demands of today's data-driven organizations.